Hello, today we're going to learn about projectile motion, an important area of science that can be applied to many aspects of everyday life. For instance, have you ever thought why objects fly in the air the way they do? Today we're going to explain the science behind the movement of objects in flight. Gravity is a key force that affects projectile motion. Gravity affects all objects in the same way, regardless of their mass, with a constant acceleration towards the Earth.
As Ty stated, gravity affects everything in the same manner, regardless of mass. To demonstrate this concept, I'm going to drop a tennis ball in a basket. As you can see, both objects hit the ground at the same time because both were acted on by an acceleration due to gravity of 9.81 meters per second squared. Gravity is instrumental in projectile motion. It causes the path of flight to take a parabolic shape. Gravity only affects the y component of projectile motion. One thing to remember though is that the rules for projectile motion only apply when air resistance is not present, like in a vacuum.
Sup bros, now we're going to explore how launch angles affect the motion of an object. The scale of an object's height and range is dictated by the angle that they're shot at, and as you approach certain angles, these two elements vary in size. The angle that maximizes the range of an object the most is 45 degrees. This is sometimes called the optimum launch angle, aka the chillest angle known to man.
If I were to fire a cannon at an angle of 45 degrees, it would go as far as it possibly could without hitting the ground. The angle that maximizes the height the most is 90 degrees. This is because all the velocity is used in the y direction and none of it is transferred to the x direction. Also, angles that add up to be 90 degrees will have the same range as long as they have the same initial velocity. In the real world, these laws hold true most of the time unless affected by outside factors like air resistance. For more on this subject, here's Miller.
Oh hey, didn't see you there. Projectile motion can be broken down into the x and y components. The x component is the horizontal velocity, and the y component is the vertical velocity. For example, I hit a golf ball with a velocity of 30 meters per second at an angle of 15 degrees to the ground. To isolate and solve for the x and y components, the first step is to draw a free body diagram. The hypotenuse is assigned a value of 30 because the ball is traveling with a velocity of 30 meters per second. You can then use sine and cosine to find the value for the x and y components. The y component is independent of the x component and can be analyzed the same way as an object launched directly upward. The x component is constant and is unaffected by the y component and can only be affected by an external force once it leaves its starting point. Now back to Ty in the lab.
Projectile motion is a very interesting and profound area of physics. It can be used to analyze and understand many real-life situations as well as other areas of physics. We hope you enjoyed the show and learned something new along the way.
And that is projectile motion.